Aha, finally got it set up here. Let me get this thing in view before we really get started. And let me calibrate the board. Okay. Is there any other questions before we move on to new material? Do you have a question? Oh, you said no, sir. I thought you said yes. Speak now or forever hold your peace. Nah, not really. You can ask questions later as well. Questions tend to be dynamic and they develop as you kind of continue to discover stuff. Okay? So let me pass out what we'll be doing today. And just like last time, once you're done with this, you can pick up your homework and you could either stay and work on your homework and ask questions. Make sure that you get to well propagate it through this way, or you may leave. But one thing's for sure, if you got a calculator, you're gonna need that cell phone, right? So that's for sure. What I will need is one of them. Give me that. Give me that. Okay. I need one of them to kind of give you guys some information about this. I'll make sure to keep it on the calibrated screen. Okay. Does everybody have theirs? Not yet? Okay. I'll start the mini lecture while it's propagating. Who here can describe to me the concept of a perimeter? Yes.
It's the line around an area.
Yeah, perfect. It's the line around an area. So like, what is the perimeter of this thing? If this is 3 and this is 4 and this is 4 and this is 3, what would be the perimeter of this shape? How'd you get that number? Add them up. So you said 4 plus a 3 plus a 4 plus a 3. That's 7 plus 7. Oh, so that's where you get the 14. Very good. So basically, what we'll be doing in this class is calculating perimeters. And they can get kind of tricky, especially on your homework. They will get kind of tricky. So at first, the problems will be pretty routine, and then they'll slightly get more fun. Because of course, it's not fun if it's easy, right? It's not impressive if you curl in 5s, okay? Maybe for grandma, okay? So it's only fun and cool if it's more difficult. And that's what I want you guys to think and truly feel. I want you guys to think, ooh, the more difficult and challenging a problem, the more excited you are, right? Even though your grade depends upon it and it's kind of stressful. Try and remove yourself from that way of thinking and try and get excited. When a challenge is posed to you, instead of allowing it to make you think, if I don't do this, I'm gonna fail. If I don't do this, I'm gonna fail. That kind of mentality will weigh you down and make you too stressed out. What you need to do is relax. Relax and treat it like it's just a fun game, like it's a mental puzzle. And then hopefully you will treat it with the right attitude, that this is just really for fun. But at the end of the day, your grade is associated to it. So make sure that you also have a kind of that in the back of your head and treat it like it's very serious, okay? So that's how you calculate perimeters. You add the distances around the shape. If you go on to 11, it's talking about getting a string. I didn't bring any strings. I probably should have. Aha. There's some strings right here. So I'm about to give you all some strings here in a little bit. But let's say you get a string. Okay. Oh, I need to get y'all some rulers, huh? I'll go to my office and get you some rulers here in a little bit. That's something that needs to happen for you to do this. So I'll go get the rulers in a minute. Let's first discuss how to do this. Notice that a string can be made into a circle, right? So really, all circles can be cut and straightened out into a line, right? Right? Yeah, it's totally true. So what you will be doing on number 11 is calculating C, which stands for circumference. Who can tell me what the circumference of a circle is? Yes, it's analogous to the perimeter of a circle. Who can tell me what the equation for it is? What is it? Pi d? Ah, so typically we say 2 pi r, but as this young lady has noted, 2r is r plus r, which is the same thing as the diameter. So you are correct. It is also expressible as pi d. Does that make sense? Get a circle? Man, this thing is running low on juice. Get a circle. Here we go. The center part of the circle is called the center. This distance from the center to any point is called the radius. Then the distance across the circle, the line that goes through the center, is called the diameter, right? This is the radius. This whole thing is the diameter, right? So when you see C, these two are equivalent to C. Man, this thing is running out of juice. Okay. When you see C, this is equal to C, the circumference. This is juicy. I like it. And then the D, when you see diameter, that is this value right here. Okay. What does C line D mean on like the chart in number 11? Yes, yes. So you will be dividing the circumference by the diameter, and then you will formulate a conclusion. Oh, take a look. The circumference equation is right there in front of us if you look past that. Then you'll get questions about circles and whatnot. Then you'll get questions about arcs, okay? An arc is a section of a circle. So let me stay on the calibrated screen here. Let's redraw a circle. Let's draw a point. Let's draw 2 points coming out of the circle right here. This little wedge out of the circle is called an arc, okay? So imagine I got a circle, okay? To measure the circle's circumference, we cut it, make it in a straight line, and measure it with a ruler, okay? Now, to do the same thing with an arc, we grab this thing right here, we grab the piece of the arc that we want, chop everything off, pretend it got chopped. And then we straighten the curve out, and we measure it. So that is the length of the arc, okay? How will we do this? Well, we talk about angles in a circle, okay? How many, and an angle is a measure of rotation, okay? So, oh, every time I talk about rotations, I have to do this, and it might not be on camera, but at least the students who showed up will get to see it. A rotation is like a 360 roundhouse kick. So whenever I do a 360 roundhouse kick or a 720 roundhouse kick, you'll notice something interesting. Notice I'm facing you straight. But if I do a spin, facing you straight. What if I do a 360 roundhouse kick coupled with a fake front kick? So, swap, facing you straight, right? So, any interval, are you all right, ma'am? Can you breathe? Do you need some sanitizer? Here you go.
I'm good at house.
You all right? All right. I'm gonna put them glasses on because everybody is blurry. And I now have to recalibrate everything. Gosh darn it. Sweet baby Jesus, I pray for the patience to deal with this right here. Okay. So, whenever you rotate in a full circle, 360 degrees, you'll land back in the same spot, right? Okay? But if you rotate in another 360 degrees again, you'll land back in the same spot. Okay. So now we define the concept of a degree. 1 degree is equal to 1/360th of a full revolution. 1 revolution is what I did. I spun around and I stopped. 2 revolutions was the fake front kick, 360 roundhouse kick, which adds up to 720. 720 degrees because it was 2 full revolutions. Okay. So we will be utilizing this principle that a degree is 1/360th of a rotation of a circle. And you'll be using this concept to calculate arc lengths. Because what is the circumference? How many degrees is in a full rotation in a circle? Yeah. So the circumference is when you rotate 360 degrees. But an arc is when you fall short of that, right? You don't get to 360. You're, let's say, at 30. Let's say at 40. Let's say at 180. Let's say at 270, right? You fall short of the full rotation. It's as if I rotated like this. All right? So I'm not facing you anymore because it wasn't a full rotation, okay? You'll be utilizing this fraction to calculate the arc length because you will say, well, the arc length, so the circumference is 2 pi r, or as this young lady mentioned, pi d, both the same thing. But if you notice that if you get 2 pi r circumference in 360 degrees, then how much would you get in, let's say, 27 degrees? Right? So you're going to have to figure that out. This is the part where you use your brains, and you use me to help you when you're stuck. Okay? I can't tell you what's up, but I can guide you to thinking about it. And I will significantly guide you if you ask me to. Okay? But I can't just like do it all for you. The point is to struggle. And then once you struggled, ask for help and I'll nudge you a little bit. Then struggle more, ask for help, nudge you a little bit. And then hopefully you get nudged to the full-fledged answer. The last questions, like 18. Nope. Oh, that was a weird noise. I should probably drink some water. Notice that 18 combines circles and normal straight lines. Yeah. And you will have to calculate both curved perimeter and straight perimeter. The straight's pretty easy. You just got to add them. The curved values, you got to use your knowledge of circumference. So notice that like in 18, the top part is not a full circle, it's half of a circle, right? So you would half this value when calculating its perimeter. Okay? I've said more than enough. Let me pass some of these around and y'all can extract strings out of it. So 2 per person, you guys can get a string out of that. There's a string for you. Yes. Say that again.
The 1/360 plus
That's a TH, like 1/360th.
Oh, okay.
That's a TH. It does look like a plus though.
Oh, that doesn't even do that.
It's a 1/360th. It's the noise in the English language th. Like a fourth, a fifth, a sixth. You get that? There we go. Oh, here you go. You guys share the string there. The string, don't get 2, but share your strings. So you share with here. String here. Okay. I'm gonna go get you guys some rulers. Yes, ma'am. Yeah. So the arc. Yeah. So.
She said we use that.
So what, let's say you want to know how much the arc of, let's say you have a circle, a radius arc, and you want to know how much of an arc length you get if you have 27 degrees. Right?
Okay. So it'll give us the degrees.
Yeah, it will give you the degrees. So you would say 27 degrees. How much of a full circle of length do I get? So you would say 360 over 2 pi r. You cancel out the degrees, and then you do the computation. That value that you get, you'll be given an r. Let's say it equals 3 or something. You'll be given an r. Then you do the calculation. Then you'll get a finite number here. That's it.
And then now we.
Yeah. Let me go get you some rulers.
Okay, thank you.
Do not steal my things. All of you. I'm watching you on camera. And do not be too loud either. I don't want people thinking I don't run a tight ship up in here while I'm gone.
Yeah, see, that's would it be? So you're gonna have to put that in. It'll be. So you know how this side is 7, and this little piece right here is 7? So that would make this side white. So it's Wait, I don't know. It's just like this. So it's not one of the use your ruler and the link I was showing off. This one right here. Yes. And then this.
Yes. That's a great question. You can leave it in terms of pi, or you can multiply it through so you can get the decimal value. Really, it's up to you. Rulers, please get one and pass it around. Rulers, get one, pass it around. If it doesn't have any units, then it is in the so it's just 47. If it did say inches, of course you have to put 47 inches.
It is expected to 12. So you cut off this section with 5 and cut off this section with 3. So subtract that from 12. 2, 5, 2, 5. For this little section?
Yeah.
Oh, I was also Professor Nail.
Yes, ma'am. Okay, I'm gonna go here and there. All right. One degree, 180. So this still holds. 1 degree is defined as 1 360 rotation. So you want to say 1 degree is 182. That's not true, right?
How do I use this formula? Let's just measure it.
Good question. Try doing this. Try converting units. You say, okay, 180 degrees. Let me multiply this times the known ratio that I have.
I see now.
Yeah, exactly. The angle, it works inside of it.
Notice that this will give you that 180 is 1/2 of a circle. I'm gonna let you think about it for a little bit. I'm gonna come back to you. Let me see what this student says. Yes, ma'am. Yes, ma'am. It is up to you. Whatever presentation is most comfortable to you, that's what I want you to do.
Well, I highlight all my answers. What's the difference?
Okay. All right. Whatever is easiest on you. One thing you can do is do your calculations on a separate piece of paper and then record them on that piece of paper. Does everybody have rulers? Yes, ma'am. Good question. How do you know what that value is? What shape did you make out of this? If you kind of extended this line here and extended the line there. Yeah. Use that hint to try and keep going with the problem. You still require.
I don't even know what to do. Like, I don't even.
All right, so you're talking about 14. Find the length of the arc of a semicircle, like half a circle, radius arc. So now that you have that, notice that you're trying to find the length of the arc. A full circle gives you 2 pi r, right? So what would half of a circle give you? Full gives you 2 pi r. What would half give you? Yeah. So multiply your result by pi r. That's right. You just keep it in the analytical expression with the variable r.
Oh, so I'm not looking for.
You can't possibly discover a finite value because you're going to be given r. Right? So what we want is a great expression in terms of the variable r. Make sense? Yeah. But if we give you r is equal to 2, then you're going to end up getting a pure number. Okay? Questions? Yes.
What are you trying to get us to include? Or don't tell us later.
I can't, I won't tell you. You don't have to command me not to tell you. I'm not going to tell you. So, is this approaching the famous number that you know that relates to circles? That's all I gotta say. Is it approaching a famous number that you know that has to do with circles? That's your name. Questions over here? Yes.
So when it comes forward to this, these,
You're gonna have to make a disc. Yeah, I didn't bring any discs. Make a disc out of your circle.
so like different shapes.
Sure. Or you use coins. You can use coins. Say I use the coins. You know what I'm saying? Yeah, really. Sure. It's whatever you want. I don't really have coins. I got a bunch of receipts and I got some dollars and I got some hair ties. There you go.
Oh.
Yes, ma'am. Oh, no. Good thing I'm here.
So does your measurement measure 1/8?
That's how we circle.
Okay, I have this, so
Find the length of the arc of a semicircle. So,
Alright, I'm gonna measure this. Okay, whatever you measure. It looks too like.
so you know this thing is true, right? You have 2 pi r of an arc in 360 degrees. How much 2 pi r will you have in 180 degrees? So what is half of 2 pi r? Now show your calculations and explain your reasoning. If you don't write it all out, and you'll show your work, you won't get full credit.
Wait, no. Yeah, so that, so it's pi times 2.
Everybody doing okay?
this is how
What happened?
2 pi r.
Oh, yeah, you don't have any spines and discs? Y'all got some change or anything? Got any coins? You can change like you can use coins, you can change the rolls, you can use some hair ties. I got some hair ties. I'm sure you guys have hair ties. You use your scrunchies or coins, yeah. Say I used a nickel, I used a penny. Stuff like that. And once you're done with those, I can maybe pass a few of them around And I'll make sure you get your coins
So
back.
circumference is
Yeah.
2 times diameter.
I'll get some coins back. I used to be the bounty hunter.
Diameter is 25. What do you mean next? And we only.
Oh, we got it.
Yeah. You like this? Yeah. So for this one, you only need, yeah. Four.
I can't really read upside down.
So for this one, we're asking for like a fourth of a circle. Okay. So what do you need? So you're just cut off, and then that would give you one half. So that would be so one, if you have a dice.
Okay.
Yeah, right?
Go back to that. 2 pi r is a full circle, and pi r is a half of a circle. And a fourth of a circle is really a fourth of a half. So what would you do with pi r?
So in order to get us a circumference, we will divide it by
Same thing, right? Well, multiply it by 1/2 and divide it by 2 for the same thing. Right? So what I'm trying to say is, yes, what you have right there is correct.
Okay, fine.
But now you know why you're correct, right? That's the difference between being correct and knowing why you're correct.
I don't know.
Yes.
Because now you need two.
That's on the syllabus.
Oh,
You don't have to look it up.
Okay.
I don't know how to get the projector.
No, it's okay. I thought we were talking about it prior.
We're supposed to, but I didn't get the projector.
Okay. So you're gonna multiply half we by this like that.
Correct.
And then divide half. Or you could just divide it by two. Yeah.
Makes sense.
No, but-
Yes, ma'am.
So this makes sense.
Yeah, but maybe. See, I have half. 360 to 180.
Oh, yeah, okay. Well, you're almost right. So the final answer has this 180. We don't need that, here's why. You want to find the circle, which means half.
Yeah.
So let's go to this argument. Here, actually, if there's 2 pi r in a full circle, how much is there in a half circle? Right. So what you really gotta do is get this squared by r and divide it by what? Yeah, you can cut it in half. So you don't need that part, no. That was just, that ratio is there to like develop your understanding of the ratio. If there's 2 pi r and a 360. Just like there will be a pi r and a 180. So what you had was technically right. I wouldn't have counted it off. But technically, it's not, because you will be dividing that 180 into that number, changing the overall value.
Yeah, okay, and then on this one.
Correct, yep.
Yeah.
So you need to get rid of this step there.
I mean, when I.
And now simplify what is 2 over 4. Simplify that. Does that make sense? That is your answer. Does that make sense?
Yeah. For diameter, 1.75 or like.
Yeah. Both. They are not only equations, they are also answers to not having a number. Because now that you have this, even any number, you can plug it in. Yeah, that's math. That's why it's so powerful. You can create generalized expressions that will fit for any number. It's so powerful because it applies to a circle of radius 1, a circle of radius of 1. It will apply to all of them.
Is this one still asking for an
Say that again. Find a way of
If I write that, we're done.
Correct, because it doesn't specify the r yet. It has not told you what a radius is, so you keep it as r, right?
Okay.
Any questions over here?
So now your section solved.
Yeah.
This one? Right, if you don't get the R given to you, you have to combine it.
What conclusion is
Find it out.
What's 20 times 5?
Oh.
Am I on the right track with this?
Yeah, what you want is some expression where you use that 2 pi r, and now you want some fraction of the 2 pi r as your final expression. That's all I'm gonna say. If you still struggle a little bit, and if it still doesn't make sense, ask again. How are we doing over here? What are you doing? You just measuring it? Oh, that? Okay, what you're doing is you're getting a circumference, getting a diameter. So make sure that whenever you measure the diameter, you're measuring fully across. Trying to keep it as circly as possible.
In order, this is reference 30
And measure from here to here.
Yeah, 630 degrees.
That then, if you do that, then yeah, you're doing it right.
What did
I just took the,
So in
I'm coming over
order,
there.
130
divided it by 360. So that I can
What's going on here?
how many times is
No, technically no. Half of the circumference is not.
Yeah, okay, I got the two.
Matter of fact, half of the circumference will most definitely always be larger. Longer. Because that curved part is curved and the diameter is straight. If you got that curved part is straight, you have of course it'll be longer than the diameter part, right? The curved top on the top, if you straighten it out, of course it'll be longer than the straight line with the diameter.
Yeah.
You see what I'm saying? Use your imagination, curved line and flatten them out.
Because there's nowhere to put that.
Math is all about imagination. Yes, ma'am. Right. You want to find how much of a circle is 30 degrees? 360 is a full circle.
Yeah.
How much of a circle is 30 degrees? Now use that fraction that you developed and multiply it times the 2 pi r, which is a full circle. Find out what fraction 30 degrees is of a circle and multiply that times a full circle. Then that'll tell you how much arc length that degree will provide you. Make sense? Well, think about it. Yeah, think about it. It's okay if it doesn't make sense. Think about it. Coming. Yes.
But that's the radius is 3.
Right. You're very close. What I would say is if the perimeter of the full circle is 8 pi, and the equation for the circumference tells you the perimeter in general, you might want to set that 8 pi equal to this 2 pi r. And then you want to solve for the radius of the break. Now follow. One by one, one by one. One by one, okay? I have here 3 questions. Yes. Yes. Does that make sense? Right. But put the pi there, so it's 8 pi, not the 3.
Wait, but then how do you get the pi?
The pi's cancel, right?
Yeah.
Yeah. Because when you say 8 pi over 2 pi, the pi's on the numerator and denominator will cancel. And then how many times does 2 go into 8? And yeah. You have a question? Okay. Does it make any sense?
I was like, it can't be that simple.
Okay. Well, okay. You are confusing the concept of circumference and diameter. Okay. Let's look at the diameter of this guy. All right, it's like that much. You measure it. Look, it's like 2. Right? But what if you just go over the whole top thing and you straighten this out? This is invariably going to be greater than 2. Look. It's way beyond 2. So it's not true that if the perimeter is 8 pi, then the top arc must be half of that. Right. Right, it's not true. So you have to, 1, use the equation, and 2, if you have a guess, come on, flip the circle, measure it, see if your guess would make sense at all. Hmm? Okay. So you just algebraically solve for arc. So you got to divide both sides by 2 pi.
No.
Yes, ma'am.
Can you guys look at these ones and let us know for the override charges?
Okay, well, one. Pick your favorite.
50.
And 1 degree is 1. Where'd you get this number here?
What?
Right, so it's already got that number. Whoa.
Yeah. How did y'all do it? We find the diameter.
I'm not saying you're wrong, but explain to me how you got that.
So,
Did you say, well, 30 divided by 360 is the same thing as 1 over 12?
I feel like I would have it a different way than I figured that answer
This is 30.
is
Right. So then you have your limit.
okay, 30 out of 60.
2 pi r divided
And then you multiply that because now you figured out that 30 degrees of a circle is 1/12 of the full circle.
Yeah.
Then you multiply that times
a
a full circle to see how much of the arc you get, right? So yes, you should cancel out this 2 with that 12. And you get what? Pi r. You get a pi r over what? Yes. Final expression with pi over 6. Alright. Now, give me some time to answer people. Raise your hand again, and I'll address the other ones.
Oh, because
I think we got it.
And you got it? Okay. Yes.
So, the whole circle is like 6. You would need 60 divided by 9.
2 questions.
So you.
Conceptually, what you're trying to do is,
These
you
ones
think,
are.
alright, 1 full circle has 360 degrees. How much of a circle is a 30 degree?
Yeah.
So you have 2.
What fraction of a circle is 30 degrees? So what you're doing is you're doing the right thing. You're saying, what is 30 divided by 360? So what does that reduce to? Right, that's going to be weird. You want to do it with fraction.
It's like right here. But instead of it being 27, it would be 180.
Yo, oops. So that is, so you figured out now using your own brain, that 30 degrees is 1/12 of a circle. So you can multiply that times the value.
Wait, I don't know.
So
You need to multiply 1/12 times
and then whatever.
the full circle. The circumference. Yes. And then simplify.
I did it.
There's 2 in the numerator, so the denominator is like multiplying. Right. So you get 5r/6, right? Makes sense? Make sure you guys understand how to calculate it, so that you can do it on your homework. Make sure you're understanding the steps. Alright? You done? Totally done? Okay. I'm gonna turn it in and I'll give you your homework. Be right there. Stapler. Here's your homework. Here's your homework.
Thank you.
Your names are on here. Very good. Okay, I'm gonna run through here. Okay. Run through like this. Yes.
Remember that this one's so you can figure out what you can get. You can figure out. No, why?
So, if a full circle is 2 what is half of it?
Why should be like a gentleman?
Half of 2 pi r, right? So you get 2 pi r and divide it by is what number? Yes.
What discs is this circle?
Discs that you create. You guys have any coins on them?
Can I just draw some?
You can draw some. Yeah, you can modulate the length of the string. You guys have any coins? I can see if I can find some coins. You guys done with your coins? I'm gonna borrow some of them. I'll give these here. Alright, make sure you return these coins to the group over here. These were different. Yes. Did it not seem to approach a famous number of mathematics relating to circles?
Oh, you know, arc is 1/4 of the circle. Well,
Ding,
that's
ding, ding.
the for the arc up there.
Yes.
So. Yes. Okay. 90 degrees. At least I'm very. No, I'm not I'm just see the
So which number? 14. Find the length of the arc of a semicircle with radius r. How much of a circle is a semicircle? Okay. How much arc length do you get in a full circle? That's a degree. How much arc length do you get? It's the same thing as circumference. all day. 2 pi r. Yeah, it's actually right in front of you. Right here, 2 pi r. So that's 360. That's a full circle. If in a full circle you get 2 pi r, how much would you get in half of a circle? Aha. What is, yeah. Make sense? There you go.
Yeah, that's fine.
Uh-huh.
Okay. I think we got it right. Yeah, that's what. So if you're finding is less.
Okay, I like what you're doing here. You're trying to see how much of a circle, what fraction of a circle is 25 degrees. So you get, okay, that's 5 over 72. Then you're multiplying it times the full circle, 2 pi r with it's pretty solid.
And then we did this, like, do you want to leave it like this, or do you want to?
Both will be sufficient. Yes,
Because this was like 370. And then you can still like plug in your arm.
Right.
And then 3/4
So basically, 2 pi r equals pi r is half of it. Pi r over 2, and then add the rest of it. So 30 plus 5.
Yeah,
So is that just how it's gonna be?
maybe.
Okay.
You tell me.
Okay.
So that's it.
That's all. Yeah. Oh, that's good. So.
Yes, ma'am. Find the length of the arc of a semicircle with radius.
Yeah.
Okay. So this 180 thing, get rid of it.
Since 1 period is on.
And if you get, you can leave it.
You've already set it up. So if in a full circle you get 2 pi r, how much will you get in half of a circle?
Okay, this is a.
Yeah, and you get pi r. Why? Because the 2's cancel.
Okay, well, then you're left with
You can't figure out from r because you're not given the r. It just stays there. It's just chilling.
Wait, can I get R?
That's it.
Wait, then what's this whole business about R equals?
Well, that's a different problem, I think, right? Who said r equals 4 centimeters?
I don't know.
You just making that up, huh? That doesn't count.
So, and then you're dividing by. So you did that makes me
Close. Gives you what fraction will you set up?
1/2 pi. Well, I still need pi r. I don't.
2 pi r divided by 4. And what's cool is that's what you said. You said 1/2 pi r. Notice that's what you get. You get pi r over 2. Yeah. Does that make sense? Go over fourths. Because now you're chopping up into fourths. It's 1/4. Is it starting to click? You guys need to, okay, don't think like that. You have to have a positive mentality. Two, you have to have a growth mindset. You know what a growth mindset means? It means with hard work and dedication, no matter where you stand, what your growth is right now, you can improve it. And you can improve it drastically. To the tutorial? What is a tutorial? Oh yeah, I'm avoiding giving times for that. 2 pi r over 4, because you're cutting the full circumference into fourths. So, does that make sense? If it doesn't, that's okay. Just let me know. So before in the semicircle, it's a half of a circle. So you cut the full amount in half to get that. Here, it's a fourth of a circle. So you're going to cut the full amount in fourths. That's it. It's as simple as that. What if I said cut it into 1/7 of a circle? You get 2 pi r over 7. Yeah, that's as easy as that. Yeah, well, you can use the 2 and the 4 out and get pi r divided by 2. Yes. Yes. Now, good. Yes, ma'am. It's about that. Use your imagination. Yes, you are. Yes, you are. Every human being has an imagination. Every human being is imagining. Aha, see? Just use your imagination. Yeah, you guys see what's going on? You guys see what's going on? So confused about that? You guys okay? Oh, one question? How much of a circle is this? How much of a circle? How much of a circle? What fraction of a circle? What fraction of a circle is this piece right here?
Okay, so that was the
Notice that if I were to combine these two, use your imagination, it'd be half of a circle. So when I split them in half and separate them, how much is each of them? Which is how much of a circle? A fourth. Ah. So you can take what you said up earlier to calculate. Do you have a question? Over here. Go ahead, your question. Yes, ma'am.
And then so it's just gonna be
17. You got 25. How much is a circle? Is it 25? It's about right. You plug in 10 for R.
Yeah, I got 12.
Okay.
Oh, 30 divided by 6. 33.
I guess it's looking very
Yeah, what's the radius?
Is that a fraction? That's
Oh.
We're still trying to.
How much of a circle is that? Oh, use that in your calculation.
Yeah.
Your questions?
Because this was 30 factors.
Oh, good question. So,
You don't have, okay,
how much of a circle is 25? So, remember how you were setting it up? Right, you don't have to guess. You can say 25 divided by what? Yep, that would be your fraction. Then, you multiply that times this quantity. 2 pi r with the r equal to 10. Then, it'll be done. Make sense? Yeah. Right? You two do everything. You have it your own individual questions? Okay.
So we just write down. I just did that all.
Yeah, but you can reduce 25 over 360.
Do we keep this?
Pardon me?
Do we keep this? Or turn it in?
You have to turn it in just like last time.
God, what if I did?
Stapler. Put your names on it. Are all your names on it?
Oh, we did separate.
You just separate? Okay. Here you go. So 30 over 360, and you figured that out?
You only know?
Ah,
You only say no? You know that? Yeah. Give it back to Michaela.
what's up? No cross multiplication needed.
Yeah.
What you do is you figure out how much of a circle is 30 degrees. Which that's what you're doing here. Then all you do is you reduce a fraction and then you keep it with R there because you're not dealing with a numerical value for R. Yeah. So 60 over 36 can simplify.
2, 1, 12. Wait, 60 over 36?
Yeah, 60 over 36. Or we're talking about 60. Yeah, 60.
Well, maybe not. I can do the calculation. 60 over 60. Yeah, it's 1/6. You see how I did it there? Yes.
Getting lesser and lesser.
So the answer is 1/6.
Times what?
Times what?
Okay. And then here's your homework.
Times 30? No.
No. Homework. Thank you.
Times 5.
Here's your homework.
One pi r, I guess. We could do this one. But that's.
Yes. Okay. Radius is 5. And you use pi r because it's half. Correct. Yeah, because it's half of the circle. And you use pi r and you replace r with the radius 5. That's correct.
Three. That's it. Okay, so right there. So it's something.
So 2 pi.
Oh,
Five over 36.
Like
So.
Yes.
What do we do with times 5?
And what's its radius? You gotta figure that out, right? Any questions? What conclusion? Okay. Are the numbers approaching a famous value?
Because R is not.
And I noticed you got your board back. I mean, you've been using this famous number in your calculation. Yes, 3.1415. Repeating with various values.
Yeah, this is your figure it out. Pi times diameter, 2 pi.
So we just.
I don't think you
Yes.
over numbers.
Yes, ma'am.
I'm sorry. For you. So we have.
Yes.
So just.
That's just one
That's right.
So it will be 1,578 over 360.
I don't know. I don't do the numbers in my head like that. That's what it nerds.
Aren't you a mathematician?
I am.
Yeah, they're just not. Okay. Did you? Oh, yeah.
Yes,
But if you do 2 pi r, like really just the diameter. Because 13 minus 7 is and then you just.
You have your base. Have all the.
Oh, well, because
You basically just base I meant for the last one.
Sorry, that's what you make us all like to do.
Okay.
2 divided by 2. 2 divided by 2. And then what is the
We don't need this to make.
I'm like, no, if I multiply all the term on top, the radius connected. So you multiply all of that, and if you get that big number, you divide that by 360.
Okay, so first. And because that, so when I try, this is 13, so you're not.
Okay. Got it.
Okay, so wait.
You guys have about 4 minutes left. If you're wrapping up, I'm willing to give you 10 minutes left, but don't push it. All right, there's a stapler right there. Here you go, trade. Trade, thanks. Here you go. Yeah, give me my strings back. I can use them next year. Next semester. Here you go. Trade. Oh, please staple this with the stapler over there. Thank you. Yes. You're saying the R is 6?
Yeah, because
The diameter is 6, correct?
diameter is 6.
R is what?
So R would be 3.
You can have it right here. Very good use of your imagination to draw a big circle there, though.
So when you find that hole, that's half versus.
That should get you.
This one is one.
I'll
for
come
count
in there.
that. So you would tell them to see, like, plug in to 40. That's-
Uh-huh.
And you did just one half.
We did.
3 times 3. Because you're rolling one, so one half times 3.
What do you mean, what about that?
We don't use that, right? Like, I don't actually.
What is this related to?
And then you just put pi at the end?
Yeah.
Okay. Two pi times.
Because if you read this wrong, then.
Two.
So 2 pi times 3 becomes 6 pi. Right? What's with this 18 times 85?
No, I feel like we're already.
There's nothing that gives you 18 times 85.
Six pi r?
6 pi r, well, 6 pi already has the r going. So go back to look at. Let me put it like this. You were trying to calculate what here? This length? Okay. So notice that this is a fourth of a circle, right? So you're gonna have to use a fourth of a circle equation, which is right here. So just replace the fourth of a circle equation with 3. Staple, and I'll get you your homework.
We wanted to know if we were doing the bottom right.
Okay, those go over there. I want my strings back too. Staple, you get this.
You want the math part too?
Yeah, why not? Stapler's over there. Get your homework.
Okay.
Here's your homework.
Oh, thank you.
Did you get a homework? Okay. Here you go.
Okay, so when you told us about this part
Mhm.
and then we plugged it in, we got that. So
Where was your work?
the multiplying,
Okay. So
sorry.
this is a fourth of a circle. So you use this with r is equal to
Right.
what? 3?
yes.
So then that should be 3 pi over 2. Yeah, good. That's right.
And so is it okay to leave it like that
Yeah.
because you can't? Okay.
Yeah.
Okay.
I accept that.
Good. Because I was like, because you can't. I mean.
No, I accept it. Do you need your homework?
I got mine.
You got a homework, so you just turn this in. Okay.
Thank you.
Did everybody get homework?
Yeah.
Yes.
Yeah. So now if you can write what we can pi 3/2. That's the full answer?
That's how much
That's the final answer, right?
contributes to the perimeter of this curved part.
So this curve is pi 3/2.
Yeah,
So if we do that, if you wanna.
you have to add that in the total perimeter calculation. But that's just one of them. Remember, there's another one here.
Right, do you add those together? Yes. And the 7 and the 5. And then it's gonna be like a weird thing?
Yeah.
Not like a number like.
That's fine. What you can do is leave it with the pi there and not multiply through pi, or you can multiply through pi. I'll accept either of those.
Okay.
So, real quick, times the R. Or you don't become
What do you mean? Well, it makes this 1/4 equation up here because it's 1/4 of the circle.
All right.
Hold it.
There you go.
Thank you, Dave. Hey, I'll make sure you have your homework.
homework?
Yes, sir.
There you go.
Thank you.
Your homework. Return those strings too. I might use them later. Ah, thank you.
I don't think that's COVID friendly.
Over there.
Is this the homework?
Oh, no, I get you. I'll get it to you here in a second. Let me put this in here. Here you go.
Oh my gosh.
Here you go.
Thank you. Can I get a homework too?
Of course. I want you guys to learn. Here you go. There you go.
Even on Thursday, I have to go on online. And sometimes it's like I don't have time to do it before getting to the class.
Did you guys get your homework?
Yeah.
Good. Okay. No problem.